Hi everyone, Victor here again, and in today's lesson, we'll look at how to create persistent volume and persistent volume claim and attach it to a pod. We'll learn how to create storage class in subsequent lessons. In the previous lesson, I explained the storage concept and I mentioned that a pod can either be attached to the local storage or a remote or shared storage. In this lesson, we'll be attaching the pod we'll be creating to a shared or remote storage. And since I don't have any physical storage array, like the likes of Dell, HP, IBM, etc., I'll be making use of another server as my remote storage and then configure NFS on the server so that the server will serve as a remote or shared storage. So without further ado, let's get started. So this is my remote storage here, which is going to be my NFS server. And if you look at the IP, you will see that it has an IP of 192.168.37.128. And this is a Red Hat Enterprise Linux 8 server. So we're going to be configuring NFS on this system, and this same step is also applicable to a Red Hat Enterprise Linux 9 system, RHEL 7 systems, CentOS 7, CentOS 8 systems. So I already have the NFS configured on this system, but I will just show you what I did. So to configure NFS on a RHEL 8 system, the first thing you need to do, of course, is to install the NFS utils. And to do that, you can just say yum install NFS utils. And because I already have this utility installed, it will tell me that it is already installed and there is nothing to do here. And when you're done installing, what you need to do is to start the RPC bind service. And to do that, you can just say systemctl start RPC bind service. And you can check the status of the service. So you can just say status. So you can see that it is started and running. And the next thing we can do is to start the NFS server as well. So I can just say systemctl start NFS server. And I can also check the status of the NFS server. So you can see that NFS server is loaded, it started, and it's running. So the next thing I'm going to do is to create the NFS shared directory. And to do that, I can just say make directory. So we're going to be sharing the directory NFS share. So I already have it created, so it should tell me that it already exists. And now I can export the share. So to export the shared directory, I need to edit the etc export file. So I can just say vi etc export. So you can see the third line here, which means we're going to be exporting this share, which is NFS share. And I have it here that I'm going to be exporting into all system, that is to the whole world. And I have some options here: read, write, sync, no sub tree check, no root squash, no all squash, and insecure. So I can save this file. And when I'm done saving this file, if you have firewall on your system, you need to add the NFS firewall rules to your system. But in this case, I'm going to be disabling firewall. And to do that, I can start RPC bind again. So I can say systemctl restart RPC bind, and I can say restart NFS server as well. So I can disable firewall D, so I can say stop firewall D. So if I say status firewall D, so I can just say status here, you can see that firewall D is stopped. But if you don't want to stop your firewall, like I said, just add the NFS rules the NFS services and ports to the firewall rules. I'll be dropping the link to this specific NFS provisioning that I have done before in the description section below, so you can see what I have here, NFS rules and all of that. So if you want to check how to configure NFS, so you can just click on this link, right? So let's go on. So we can now export the shares. So I can just say export FSA. I can add variables and I can even say re-export if I wish. So you can see that I'm going to be exporting the NFS share directory, and I can also confirm by saying show mount. So you can say show mount -e localhost. So you can see that we're going to be exporting this to the entire world. So this is how you would configure your NFS server. So like I have said, this server is acting like our remote storage, right? So if I already did this, like I told you, so if I do df-h, you can see that the NFS share directory is mounted on a disk itself. So it's mounted on dev SDA1 disk and it has a size of 13 gig. So this is our remote storage in this case. And since this is our remote storage, of course, you should know that Kubernetes would not manage your storage for you. You will be the one to manage your storage by yourself, to do your backups, to do all the management as regards your remote storage. So now that we've done this, we need to go back to our cluster environment. So now I am on the OpenShift cluster server. And what we're going to do on the NFS client side is also to install the NFS utils. And to do that, I can just say dnf install NFS utils. So you can say yes to all options. This command needs to be run as a root user. So this is going to install the NFS utils for us. So I'm just going to pause the video, and when the installation is done, I'm going to resume the video. So now I can start the RPC bind service. So I can just say sudo systemctl start RPC bind. So I can verify that it's been started. So you can see that the service is active and it's running. So now let's verify that the NFS share directory is available on our cluster node. And to do that, I can just say show mount -e followed by the NFS server IP, which is 192.168.37.128. So you can see that the share is available, and the share is NFS share, just as we created it on the NFS server. And this is being shared to the whole world. And now that we've been able to verify this, let's try to mount it to the shared directory. So I'm going to just mount this to /mnt, is just for me to be able to be sure that I can mount this directory. So I can just say sudo mount. This is going to be -t nfs 192.168.37/128. Then this is going to be /nfs share. Let me mount this to /mnt. All right, so I can confirm that this has been mounted. So I can just do df-h. So you can see that this has been mounted. You can see the share here. So this is good. We've been able to verify that we can reach our shared storage, which is the NFS server. So now I'm just going to unmount this. So I can just say umount slash mnt. Oops, just say sudo bang bang. So if I do df-h, so this has also been unmounted. All right. So we have our shared storage available, and we also have our cluster node. This is the OpenShift cluster available. So what we're going to do now is to create the persistent volume. And to create the persistent volume, we can use the YAML manifest file. And I already have one here, which is in I think I have it as pv.yml. All right, so this is a YAML manifest file for persistent volume. And I don't need to start explaining this from the scratch again because I've explained this in one of our previous lessons. I've explained all the syntaxes of how a YAML file should be. And if you look at this, you can see that we have our API version to be v1, and the kind is persistent volume. This is the name of the persistent volume, which is pv-1. And if you look at the spec section, we have the storage class name, and I gave it a name to be static. So this storage class name is an important parameter that must be included in the persistent volume YAML manifest file. However, this is not a storage class object. So if you look at the capacity, you see that we have 13 gig. So the NFS shared LUN that we created was actually 13 gig. So you can make this to be 13 gig or lesser than 13 gig, however, whichever way you want it. And we also have access modes. The access mode is read write many. So let's even understand what access modes is. If you check the Kubernetes website, you will see the access modes. So for the read-write ones, you can say that it's saying that the volume can be mounted as read-write by a single node. So this simply means that, for example, if you have a pod running on different nodes, this means that the volume will only be mounted on one node as read-write. So only one node will be able to read and write, while the other nodes will be able to read only. And for read-only many, you can see that it's saying that the volume can be mounted as read only by many nodes. So this means that all the nodes in the cluster can just be able to read the volume only. And for the read write many, it's saying that the volume can be mounted as read write by many nodes. So meaning that the volume will be mounted on all the nodes as read write. And we also have read write once pod. And if you don't want to write it in full, you can see the abbreviations in the CLI mode. And also, you can see NFS here. So NFS is the type of persistent volume. So we have different types of persistent volume in Kubernetes and OpenShift, of course. So let me show you that too as well. So if you come here, types of persistent volumes. So we have the Ceph FS, we have the FC fiber channel storage. Like I said, you'll be the one to provision a remote storage, and if your remote storage is the one that uses fiber channel, of course, you're going to be using the FC protocol. You have the host path. So this is just like a directory on your node. And you can see, like I said, it said it's just for a single node testing only. So this is more or less like a local storage, like what I've explained. And we have the iSCSI, we have the local, we have the NFS, we have the RBD. So we are using the NFS type of persistent volume. And this is the NFS server IP address, and also this is the path for the NFS. So we can just save this and create the persistent volume. And to do that, I'll just say also create file pv.yml. So you can see that the persistent volume pv-1 has been created, and I can just do also get PV to verify that. So you can see that we have the PV being created here, which is PV dash lon1. So this is the default one by OpenShift. All right, so now that we have our PV being created, let me just quickly explain a few things here. So if you look at, let me make this a little bit bigger. Let's see what I can do here. So if I do also get PV, all right, so if you look at this here, you can see that I have the capacity here. I have the access mode. Well, I'm not seeing it the way I want you guys to see it. Let me just drag this a little bit. 1 minute. Just want to see how I can make this a little bit bigger. All right. Okay, this is better. So the capacity, let me make this bigger a little bit. I mean, it's just to get PV. All right, so you can see that I have the capacity to be 13 gig, and that's the capacity of this persistent volume. And you can see the access mode, which is this read write many, and you can see that the reclaim policy is retained, right? And you can see that the status here is available, meaning that this PV is available. And you can also see that this claim here, there is nothing here. So it means that this PV is available and it has not been claimed by any PVC, right? And you can see that this is the name of the storage class, which is static. So let's even still understand what this reclaim policy means. Let's understand what retain reclaim policy is. So when a user is done with their volume, they can either retain the volume. So this is what it means. If your reclaim policy is retained, this means that when the PVC associated to that PV is deleted, or even when the pod that is using that PV is deleted, the data will still exist. So we're saying the persistent volume still exists and the volume is considered released. So that's the retain policy. And we also have the recycle policy and we also have the delete policy. So the delete policy simply means that when you delete a PVC that is mapped to a PV, it means that the data in the PV2 will also be deleted. So you can choose whatever reclaim policy you want to use, and you should also know that a PV to PVC binding is actually a one-to-one mapping. You will get to know more about it when we get to the PVC side. And I also want to talk about this storage class again. I can see that the name of the storage class is static. So it's just a storage class name, and it is a requirement in creating a PV. And the reason is because if you don't give a storage class a name, the PVC will be bound to the default storage class and not the PV. So if you do OC get storage class, you would see the default storage class. So that's why you would need to create a storage class name and give it any name so that it will not be bound to the default storage class. And even if you don't want to give a storage class any name, you can just use double inverted comma. That too works well. So now that we've created our PV, let's create our PVC. And for the PVC, I also have a YAML manifest file for that. So if I do vi, let me just do cat pvc.yaml. So if you look at this as well, you would see that I have the API version, the kind is persistent volume claim, and this is the name of the PVC, which is nginx-pvc. And under the spec section, you can see that the storage class name is static. So the same name you gave in your PV has to be the same here in the PVC, and in the PV we gave it to be static, we named it rather to be static. And so I'm just trying to say that we are creating this manually, we're creating the PV manually. So that's why I just named it static. You can name it, you can give it any name you wish. And also for the access modes, you see that we also have read write many. So the same access modes that you have in your PV is what you're also going to be giving your PVC as well. And for the resources, you see that we're requesting for the storage size of 10 gig. You can also request for any amount of storage size you want to request for. So now let's create this PVC. So I can just say OC create file pvc.yaml. So you can see that the PVC has been created. So if I do OC get PVC, so you can see now that this is the name of the PVC, and the status is that it's been bound, right? And it's been bound to this volume, which is PV-1, and the volume has a 13 gigabyte capacity. That's the volume that it's been bound to, and the access mode is read write many, and the name of the storage class is static. So if I do OC get PV again, you would see here that now you will see that the let me try and show you where the access mode retain policy status. So this is what I want to show you. You can see that the status now is bound. So it's been bound to this PVC. So now that we have the PV object and the PVC object being created, the next thing we're going to do is to create a pod that will make use of the persistent volume. Let me just clear my screen. So I already have the YAML manifest file for the pod that we're going to be creating. So I just have it in nginx.yaml. So if you look at this manifest file, you can see that it's following the same convention. We have the kind, which is the deployment, metadata, we have template, and here for the container section, we have the container name and the image and the port. So what you should know is that you're going to be mapping the volume to the port first, and then connect or attach or map the volume from the pod to the container that will be using the volume. And the reason is that a pod can have more than one container, and you might just want a container in the pod to use the volume and not all the containers. Hence, the reason why the volume is mapped to the pod, and then from the pod to the container or to a particular container that will be using the volume. And in this case, we only have one container in the pod. So what we're going to do first is to map the volume to the pod first. And to do that, of course, you can see that after the spec section here, you have the templates and we have the spec. So this is the container section. So I'm not going to be having the parameter under the container section, right? Because this is the parameter for the container. So I'm going to be having the parameter under spec section. So meaning that I want to map the volume to the pod first and not to the container, right? So you can see that after under the spec section here, I can have a parameter called volumes. So meaning that I'm mapping into the pod first. And for volumes here, I can have the name of the volume, right? So I can just say name. I can give it any name. I can say nginx volume. And after which I'm going to have the type of volume, and I can call it type of volume rather is persistent volume claim, and the persistent volume claim would have a claim name which we created. So I can say claim name. The claim name which is an nginx PVC. So by doing this, we've been able to map or attach the volume to the pod. Now we can attach or map this volume from the pod to the container. And to do that, so that means we need to write these parameters now under the container section. So you will see here that under the container section, we have container name image port. So after which I can have volume mount, right? So here I can just say, let me leave a space. So here I can just say that on the port, I can just say volume mount, volume mount, right? Let me close it so you can really understand what we're doing. So volume mount. So for volume mount, I can have the name of the volume, and the name here. The name of the volume is Nginx dash volume. It's going to be Nginx dash volume, and the mount path. So this is going to be mount path is going to be, we're going to be mounting this volume in the path which slash usr slash share slash nginx slash html. So the volume is going to be mounted in this path in the container. So now I can save this file. So let's create this pod. It's going to be file nginx.yaml. So you can see now that the deployment has been created. And if I do OC get pods, you can see that the container is running. So I can just put watch here till the container is being created. So the container is already running now, which is fine. So I can say OC get pods again. So the container is running. If I do OC describe pod, let me just copy the pod name here. So if you look at the pod, the description of the pod here, let's see the mount. So you can see that this thing is mounted, the volume is mounted in slash USR share from where? From Nginx volume, which is read and write. And if you look at, let's look at the volume section, it should be somewhere here. Volume section should be somewhere here. So I can show it to you. Okay, so this is the volume section. So you can see that we have nginx-volume and the type is persistent volume claim. And you can see that the claim name is nginx-pvc. Alright, so what we can now do is this. Since we have a shared storage being attached to this pod, so what we can do, or to this container rather, so what we can do is to create some files in this container and check and verify if that file is going to be written on the shared storage. And to do that, so let me just log into the container. I can just say OC, let me say OC get ports again. So I can just say OC, let me use this so that I can log in straight away, like the way we've been doing it before. I don't want to go through this CRC notes, so I'll just use this command straight away to get into the pod. So I'll just copy this and do paste. Let's say sh. Okay, saying this is deprecated. All right, so what I can do now is to go to cd slash user slash share slash nginx slash html where we mounted the volume to, and if I do ls, so I have some files here. So let me do touch test file 2. If I do ls, so now let's go back to this is the oops Okay, I want to go back to the remote to the shared storage and see if we can, if we can see this file that we created. This is the remote. Yeah, so I can just log in here. So here I can do this is NFS share here. So if I do IP-A, so this is the shared storage. Let me confirm that, yeah, that's the 128, and I'm in NFS share. So if I do ls, so you can see the file that we created, which is test file 2, meaning that even if our pod should crash, we're still going to have our data intact inside of our shared storage. So even if let's do something again. So let me just create another file. Say touch test file 3. I do ls, and let's see ls here. So you can see test file 3 here too as well. So what I'm going to do is to delete this port. So let me just exit out of this. So I can just say OC delete file nginx3 nginx.yml. So this should delete the port and say OC get ports. Okay, so let's even confirm if we still have our information intact. So if I do ls, so you can see that our information is still intact. So thank you for watching. In the next lesson, we're going to see how to use config map and secret, how to map those as volumes inside of a container. So thank you once more for watching, and I'll see you in the next lesson. Please don't forget to subscribe, share, like, comment. And if you do that, that would encourage us to do more of this. So thanks once more, and bye for now.